California has wet years and dry years. We have droughts, we have floods. The last 3 years now have been a drought for California. I would argue it was a drought before the governor made an official declaration. But the official declaration of drought does a number of things. One thing it does is it causes people to pay more attention. It calls attention to the nature of the problem, the severity of the problem, the need to take some action. In this case, the governor also offered some financial assistance to be made available to people suffering severe economic impacts of the drought.
We use water in a variety of ways in California. About 80% of the developed water supply, that's the supply that humans use, about 80% of that is for agriculture. They're a major user. The remaining 20% is for cities. That's water we're using in our urban areas, both indoors and outdoors, in our homes, in our businesses, and also in our schools. In a drought, there are many restrictions that come into play, either mandatory or just simply because the water isn't there and we can't use it. So typically our water use is lower during droughts. That's because we're not watering our landscapes as much. Agriculture in some cases may be forced to fallow. Agriculture has done a lot though. They are using water more efficiently than they were 10 and 15 years ago, but there's more they can be doing and more they'll have to be doing because of the drought.
At the individual level, we can wash our clothes with efficient washing machines rather than inefficient washing machines. We can flush our toilets with the smart new high-efficiency toilets. There are also behavioral things that we can do. We can change our behavior in the short run, and we do. We let our lawns go brown, or we don't wash our car as often or at all. And those voluntary short-term measures can be very effective. There are two major things we can do. One is cut our demand and become more efficient. The other is look at alternative sources of supply.
There are potential to capture stormwater, to then use that water and recharge our groundwater aquifers. We could be doing more rainwater harvesting or using rainwater cisterns to, again, capture stormwater so that we can use it when we have a drought. We can also be looking at recycled water. There's a lot of opportunity to take water that's been used, to treat it again, and then to use it again to recharge aquifers, to use it for landscaping, to use it for industrial processes. And so there's significant opportunity there as well.
In the long run, we could look at desalination. There's a lot of ocean water out there, but it's an extremely expensive source of new water. I think we'll see more and more desalination over the years, but we should do the things that make economic sense first. But the truth is, even in a wet year, even in a normal year or a wet year, we don't have as much water as we would like. And so some of these things that we have to do for a drought, we really ought to be doing full time. We ought to be doing in a permanent way.
If you look back over time, all of your extreme events in California are caused by atmospheric rivers.
An atmospheric river is a corridor of water vapor that on Earth they are formed in the tropics and they're carried in these narrow streams thousands of miles, and then they eventually hit land. And when they hit land and they encounter mountain chains, you get large amounts of precipitation. It actually turns out it's kind of an escape valve of all this energy and water vapor that's formed in the tropics that is carried poleward.
On average, in California, you'll see 5 to 7 atmospheric rivers during the winter season.
30 to 50% of our water resources come from these atmospheric river storms.
Not all atmospheric rivers create floods, but if you look back historically to the floods in California, most of the floods that do occur are caused by atmospheric rivers.
The history of atmospheric river storms goes back about a couple thousand years. We have records of huge floods that occurred on average every 1 to 2 centuries, that we have strong evidence that those are formed from atmospheric rivers. The largest flood that we've had in California was in 1861, 1862, that winter. And although most people don't know about it, it inundated huge areas of the state. The Central Valley, 300 miles long, 20 or 50 miles wide, was under at least 10 feet of water. It was such a disaster that the state went bankrupt, and thousands of lives were probably taken. We haven't had anything like that since.
We're in the town of Bodega Bay, installing what's called an atmospheric river observatory. It's a collection of high-tech instruments that are really designed to probe the atmosphere and figure out what's causing the extreme events. We use the instruments to tell us what's going on with the winds and the water vapor transport. And there'll be 4 of these installed along the California coast. Monitoring the conditions continuously year-round will also give us a hint on how climate is affecting weather in California.
We haven't had a major atmospheric river storm since 1861. We haven't had a major drought. I mean, the longest drought we've had has been 6 years. And yet we've seen that in the past, droughts can last for decades, if not over a century. It's important to understand our climate history and to understand where our water comes from and how we should really be preparing now for a drier world, but also a world that may have bigger floods.
Ocean acidification is a phenomenon that we're experiencing now due to the fact that the ocean is absorbing, like a sponge, carbon dioxide that we produce.
As CO2 is absorbed by the ocean, it changes the chemistry, which can cause the oceans to become more acidic.
We know that ocean pH is changing, and that in itself is alarming.
You can acidify any liquid just by taking a straw and blowing through it into a glass of water. And the CO2 in your breath is introduced into the water and causes a dropping of the pH in the water. Same thing is happening in the ocean. In the last 250 years or so, the acid levels in the ocean have increased 25 to 30%. And this is directly measurable. You can go out into the ocean with special meters and you can measure that increase in acidification.
As you increase the concentration of carbon dioxide in the water, you're actually going to affect ocean organisms physiologically and affect their metabolism. It's like they're breathing into a brown paper bag.
You lose some of the species you would expect to be really sensitive, and these are species with shells.
Many organisms in the ocean build skeletons out of calcium carbonate, which is basically chalk. Clams, corals, snails, many organisms use this material for their skeletons. Ocean acidification, it will literally dissolve some of the shell. It will affect the structural integrity of the shell. And this is a skeleton of the animal. Think of your own skeletons basically becoming a little bit rubbery.
Oysters are ecologically important. They filter water, they provide habitat for a lot of other organisms at the base of the food chain.
We're beginning to see effects in microscopic planktonic organisms in the Southern Ocean, and that's alarming because some of these microplankton are responsible for producing much of the food at the base of the food chain.
We are all connected.
We depend on the ocean for our economies. Out here on the West Coast, for example, one of the areas of concern is oyster farming.
We can already see how economies are being affected. We've had a response to the $300 million potential loss of a huge economy through the oyster fishery in the state of Washington. There's actually been a response on the part of the government recognizing explicitly that this is going to be an issue. It's going to be an enormous impact on coastal communities and in the way that a lot of people make their living.
I think other states will follow. I think California should be paying attention to this.
The number one thing that we can do to combat ocean acidification is to stop burning fossil fuels. Burning fossil fuels has been one giant chemistry experiment threatening the oceans that give us life. If we can turn toward clean and renewable energy sources, and if we can tell our friends and our elected officials about ocean acidification, we can leave those chemistry experiments in the classroom and start being part of the solution. The oceans don't have a voice, so if we can use our voices in the classroom, in our offices, on social media, at the dinner table, we can educate people, we can inspire people, and we can ultimately be leaders for the ocean and for the people that depend on it.